What if we are not the first? Not the first civilization. Not the first species to reshape a planet, to burn through resources, to leave a mark on the chemistry of the atmosphere and ocean. Not the first to rise and then, perhaps, fall so completely that almost nothing readable survived. That question has been circulating in serious scientific literature for years now, and the version of it that matters most was published in 2018 by researchers working with NASA-affiliated institutions. It was not fringe speculation. It was a peer-reviewed paper asking, with measured and careful language, whether a prior technological species could have existed on Earth and left a signature so faint that we have been studying it for decades without recognizing what it actually was. The paper pointed to a specific moment in the geological record, 56 million years ago, a carbon anomaly so large and so chemically strange that 30 years of active research have not produced a complete natural explanation for it. A fingerprint with no owner attached to it. That is the part of this story that tends to get quietly set aside. Not the anomaly itself. Scientists have named it, measured it from thousands of ocean core samples pulled from every major body of water on Earth, published hundreds of papers about its chemistry, its timing, its biological consequences. All of that is documented and confirmed and not in serious dispute. What remains disputed, what has remained open for 30 years, is the cause. And the reason that matters is not whether something was here before us. The reason it matters is why we are so reluctant to say it out loud. If you enjoy what comes next, consider subscribing and leaving a like. Let's begin. The geological record sounds like a history book. It sounds like something you could read, page by page, moving backward through time, watching continents drift and species rise and extinctions arrive like punctuation marks in a very long sentence. That impression is understandable, and it is almost entirely wrong. What the geological record actually preserves is chemistry. Not events, not causes, not the stories behind what happened, just the chemical aftermath. The sediment layers that geologists core out of the ocean floor are not a narrative. They are a residue. They are what was left behind after something occurred, compressed by time and pressure into a chemical signature that persists long after whatever created is completely gone. The difference between those two things, a record and a residue, is the first thing to understand, and it changes everything that follows. Think about what happens after a fire burns down a building. When investigators arrive the next morning, they find ash, they find charred structural material, they find heat signatures burned into the surrounding soil where temperatures reach their peak. From all of that, they can tell with considerable confidence that a fire occurred. They can estimate how hot it burned, how long it lasted, roughly where it started. They can read the chemical aftermath of the event with real precision. But they cannot tell you from the ash what the building looked like before it burned. They cannot tell you how many floors it had, or whether anyone lived there or who built it, or why it was constructed in the first place. That information is gone. Not missing, not filed somewhere else, gone. Transformed by heat into a form that no longer carries it. The chemistry survived. The story did not. The geological record works on exactly the same principle, operating across timescales that make any single human life feel like a spark that barely registered. A chemical event that happened 56 million years ago left its signature in the sediment of every ocean on Earth. And that signature is real and readable and thoroughly confirmed. Geologists have drilled it out of the Atlantic and the Pacific and the Indian Ocean and the Southern Ocean. They have pulled it from thousands of separate core samples and found the same chemical shift written into the rock at the same moment in time, the same moment everywhere, because whatever caused it was planetary in scale. The chemistry is there. It is not in dispute. And the chemistry tells us, with a precision that is difficult to overstate, what happened to the planet. What it cannot tell us, what no amount of further sampling will ever tell us, is the complete story of what caused it. The record preserved the aftermath. Whatever preceded it has been transformed beyond recognition, or buried beyond recovery, or simply erased by the 56 million years that followed. The event itself has a name. Scientists call it the Paleocene-Eocene thermal maximum, though most of the literature shortens it to the PETM, and the name is almost too clinical for what the data actually describes. Between 3 trillion and 7 trillion tons of carbon entered the atmosphere and ocean in what was, by geological standards, an extremely short period of time. To hold that number for a moment, 3 trillion tons at the low end, 7 trillion at the high. If you stacked 1 trillion of anything, the stack would dwarf all recorded human activity combined. These are not numbers that resolve easily into human intuition, but the Earth's chemistry absorbed them and recorded them, and that record shows temperatures climbing by as much as 8 degrees Celsius across the span of the event. 8 degrees. The difference between the world you are living in and the world that existed before the industrial era is roughly 1 degree, and the consequences of that single degree are already reshaping coastlines and weather systems and species ranges across every continent. The PETM imposed 8 times that shift. It did not impose it gradually across centuries of slow policy debate. It imposed it fast enough to register as a sudden discontinuity in the chemical record. Fast, by the standard of a planet that counts its time in millions of years. And then, there is what that warming did to the things living in it. 1/3 of all deep-sea life went extinct. Not declined, not struggled, extinct. The deep ocean, which buffers against surface conditions more effectively than almost any other environment on Earth, could not absorb what the PETM delivered. Species that had persisted through prior upheavals, that had survived the slow pressure of changing ocean chemistry over millions of years, simply stopped appearing in the sediment record at a precise moment and never returned. When you find that kind of pattern in a core sample, a species present in one layer, absent in every layer above it, without recovery, that is not a climate shift. That is a killing. The planet spent 200,000 years returning to something resembling stability. 200,000 years. The entire recorded history of human civilization, from the earliest writing systems to the present moment, spans roughly 5,000 years. The PETM's recovery period is 40 times that. If you compress the recovery alone into the length of a single human life of 80 years, recorded human civilization would occupy less than 2 years of it. The Earth did not bounce back quickly. It absorbed the damage across a time span so large that it makes the event itself feel almost patient. And the chemistry of the carbon is the part that matters most. Geochemists can read where carbon came from by examining the ratio of its isotopes, specifically carbon-12 and carbon-13, which are versions of the same element that differ slightly in weight. Living things, as they process carbon through biological systems, preferentially absorb the lighter version, carbon-12. This means that biological carbon that passed through living organisms, carries a distinctive isotopic signature, a lower ratio of carbon-13 relative to carbon-12. Volcanic carbon, by contrast, which has never passed through any biological system, carries more carbon-13. Geochemists use this distinction the way a doctor uses a blood type. It tells you where the carbon came from. It is reliable, it is well established, and it is not a method that is in serious dispute anywhere in the scientific community. The carbon released during the PETM carries the biological signature, not the volcanic signature, the biological one. It is light carbon, the kind that passed through living things before it entered the atmosphere and ocean. 3 to 7 trillion tons of it, with the isotopic fingerprint of biology. And that open question, what living source, what biological process could have released that volume of carbon that quickly, is exactly where the next piece of this story begins. So what was it? That is the question that has occupied geochemists and paleoclimatologists for the better part of 3 decades. Not as a fringe curiosity, not as an open philosophical puzzle sitting on the margins of the discipline, but as a genuine unresolved problem sitting at the center of some of the most carefully published work in Earth science. Thousands of core samples confirmed the event. Hundreds of papers characterized its chemistry. The isotope fingerprinting established beyond serious dispute that the carbon was biological, and then, consistently, the literature runs into the same wall. The sources proposed to explain the carbon do not add up to the carbon that was released. The volcanoes were considered first, and seriously. There is a geological feature associated with the PETM called the North Atlantic Igneous Province, a massive episode of volcanic activity that coincided approximately with the event and released carbon on a scale that dwarfs anything in the recent human record. This was a reasonable candidate. Large igneous provinces are responsible for some of the most severe disruptions in Earth's history, including extinction events, and when you are looking for something capable of moving carbon at scale, volcanic systems are where you look first. But the isotope problem does not go away simply because the volume is large. Volcanic carbon carries more carbon-13. The carbon at the PETM carries less. The fingerprint does not match. The volcanoes were large enough to have contributed to the warming in some models, but they cannot account for the biological signature of the carbon that actually entered the record. You cannot explain a biological fingerprint with a geological source. The chemistry is not ambiguous on this point. So the explanation shifted towards something called methane clathrates, which are structures in which methane gas becomes trapped inside frozen water molecules at the ocean floor, forming a kind of ice-locked reservoir of ancient organic material. The idea is that warming ocean temperatures could have destabilized these clathrates, releasing enormous quantities of methane, a biological carbon source, into the atmosphere and ocean. This is sometimes called the clathrate gun hypothesis, and it has genuine scientific support as a contributing mechanism. Methane released from clathrates would carry the biological isotope signature. Because the methane itself was produced by microbial organisms decomposing organic matter over long timescales, the fingerprint would fit. The problem is the volume. The estimated size of the clathrate reservoir at the relevant time, combined with reasonable models of how much could have destabilized and how quickly, does not approach 3 to 7 trillion tons. The clathrates are a real mechanism with the right chemistry, and they almost certainly contributed. They do not close the gap. They narrow it. Orbital shifts were examined as a forcing mechanism, variations in Earth's position relative to the Sun that could drive warming and trigger secondary carbon releases. These are real. The Milankovitch cycles describe how Earth's orbital parameters change over tens of thousands of years, and how those changes influence climate. But orbital forcing operates on timescales that do not match the abruptness of the PETM's onset. And more critically, orbital shifts do not themselves release carbon. They can push climate toward thresholds that cause other things to release carbon. As a trigger, the mechanism is plausible. As an explanation for the volume, it is not sufficient on its own. It simply moves the question back one step. If orbital forcing triggered the release, what reservoir held 3 to 7 trillion tons of biological carbon waiting to be triggered? And this is where you arrive at something the literature handles with measured precision, but which is, if you follow it to its logical edge, genuinely unsettling. The gap, the difference between what the known natural sources can account for and what the chemistry actually shows was released, has been noted in published research consistently across 30 years of investigation. 30 years. In a discipline where individual studies take years to design, execute, and publish, 30 years of consistent failure to close a gap is not a rounding error. That is not a problem that simply has not been solved yet. That is a problem that has been looked at from many angles, with increasingly sophisticated tools, by researchers at serious institutions, and has not yielded a satisfying answer. Here is my position on that. The gap is not a sign that the science is wrong. The measurement is solid. The isotope analysis is reliable. The volume estimates, while carrying uncertainty, are consistent across independent methodologies. The gap simply means that something produced 3 to 7 trillion tons of biologically fingerprinted carbon in a geologically short period, and that whatever it was has not been explained by any natural source that has been proposed and tested over 30 years of active research. The honest answer is that we do not know what caused it, not completely. And that open answer is exactly where the next piece of this story begins. In 2018, a NASA scientist named Gavin Schmidt and a physicist named Adam Frank published a paper with a straightforward title and an uncomfortable conclusion. The paper was not sensational in tone. It was the opposite, careful, methodical, almost dry in its framing. What Schmidt and Frank were asking was a question that sounds simple until you actually sit with it. If an industrial civilization had existed on Earth tens of millions of years before us, what would remain of it? And would we be able to recognize it for what it was? They were not claiming anything had existed. They were building a model. And the model, followed honestly to its conclusions, produces something that is genuinely difficult to set aside. The assumption most people carry, the one that feels obvious, almost self-evident, is that if something had been here before us, we would know. We would find the bones, the tools, the foundations of buildings, the residue of cities. The absence of those things feels like an answer. It feels like confirmation that nothing came before. But that assumption is only reasonable if you understand how geological time treats physical materials, and the truth of that is something the intuition is not built to process without being walked through it carefully. Concrete, the material that modern civilization has poured across hundreds of millions of square kilometers of the planet's surface, begins breaking down within thousands of years. Not millions, thousands. The chemistry that holds it together, the calcium silicate hydrate structure that gives it rigidity, is soluble over geological timescales. Given the right environmental conditions, moisture, pressure, the slow chemistry of burial, concrete becomes unrecognizable within a window of time that sounds long to a human being, but is, in geological terms, barely a breath. Steel corrodes within tens of thousands of years. The iron oxidizes, the structure loses integrity, and over the kind of timescales that the geological record operates on, it returns to the mineral forms it came from. You could not distinguish the corroded remains of a steel beam from the natural iron deposits in surrounding rock after enough time had passed. Plastic, which we have produced in quantities sufficient to coat the entire surface of the Earth in a measurable layer, degrades within centuries to a few millennia at the outside. Some components persist longer in specific burial conditions, but the structures, the bottles, the pipes, the panels, are gone within a geological eye blink. Nuclear waste, which we often think of as the most permanent thing we produce, fades isotopically over millions of years. The signature of enriched isotopes that distinguish human-processed nuclear material from natural background radiation becomes indistinguishable from natural variation across that timescale. Sit with what this actually means. If a civilization had existed 50 million years ago, had built cities, burned fuel, transformed the chemistry of its atmosphere, and then ended, there would be no bones arranged in useful poses, no tools, no foundations, no structures of any kind waiting for us to excavate. 50 million years is not a duration that physical objects survive in recognizable form. The gap between 50 million years and the age of recorded human civilization is so extreme that comparing them directly almost doesn't function as a comparison. Everything physical would be gone, transformed, dissolved, compressed, recycled through the geological system. Just chemistry. What would remain is what always remains across those timescales. A thin layer in ancient rock, detectable not by its shape but by its composition. Readable not as a ruin, but as a signal in the ratios of elements and isotopes that geochemists know how to measure. Just chemistry, preserved in stone, waiting for someone who knows what they are looking at. And this is where Schmidt and Frank's model becomes something more than an abstract thought experiment, because they did not stop at demonstrating that physical evidence would vanish. They went further and asked what chemical signature an industrial civilization would leave behind that could survive 50 million years of geological processing. Their answer was specific. An industrial civilization burns biological carbon, oil, gas, coal, organic matter accumulated over millions of years. That combustion releases enormous volumes of biologically fingerprinted carbon into the atmosphere and ocean. The isotope signature of that carbon is light. It carries the mark of biological origin. The volume, at industrial scale sustained over even a few centuries, would be measured in the trillions of tons. The rate of release, concentrated into a geologically short window, would appear in the record as an abrupt spike, not gradual, not the slow accumulation of a volcanic province operating over millions of years, but fast. And after the civilization ended, for whatever reason it ended, the long recovery would begin, taking hundreds of thousands of years to rebalance. The model predicts a biological carbon fingerprint. The PETM has one. The model predicts a volume exceeding what known natural sources can account for. The PETM has one. The model predicts a rate of release comparable to industrial output, compressed into a geologically brief window. The PETM has that. The model predicts that the source would remain unexplained by natural mechanisms despite sustained investigation. The PETM has been investigated for 30 years, and the gap has not been closed. This is not an approximate match. This is not a loose resemblance that requires generosity to see. The predictions from the model and the measurements from the geological record align, point by point, in the specific ways that matter to a geochemist reading a core sample. That is where the question lands. Two independent lines of work. One building a model from first principles about what industrial activity leaves behind. One measuring an anomaly in ancient rock with no satisfying natural explanation, converge on the same signal. And the question that has been almost entirely absent from the formal scientific literature since 2018 is the one that follows naturally from that convergence. And the question that follows naturally from that convergence is one that almost no one in a position to investigate it has chosen to ask out loud. That is not a small thing. 7 years of institutional silence on a formally published, peer-reviewed paper from a NASA scientist and a university physicist is not what happens when a question is simply overlooked. Overlooked questions get picked up by graduate students looking for dissertation material, by researchers at the margins of a field who want something provocative to build a career around, by the kind of curious generalist scientist who reads across disciplines on weekends. 7 years of near-total institutional silence is something different. It is what happens when the professional cost of engaging with a question is high enough that even curious people decide, quietly and individually, that it is not worth the risk. Because the asymmetry here is real, and it matters more than most people outside academic science fully appreciate. If you are a geochemist with a solid reputation and a functioning career, and you decide to formally investigate whether the PETM could represent the chemical residue of a prior technological civilization, you are making a specific kind of wager. You are wagering that the evidence will be strong enough, and the methodology clean enough, and the conclusions careful enough, that your colleagues will read the work and see rigor rather than speculation. And if you are wrong, if the evidence does not hold, if a natural explanation closes the gap before your paper goes through review, if the community decides you reach too far, the word that attaches to your name is not ambitious, it is not bold, it is the one who published that paper. That association does not dissolve after a single bad review. It follows a researcher through grant applications and hiring committees and conference introductions for years, sometimes for the remainder of a career. The cost of being wrong on this specific question, in this specific field, at this specific moment in the history of the science, is asymmetric in a way that makes silence the rational choice, even for people who find the question genuinely worth pursuing. And staying silent costs nothing. Not professionally, not institutionally, not in any currency that the scientific system actually tracks. You do not lose a grant by declining to follow up on a published paper. You do not lose a position by focusing on questions that carry less reputational risk. The incentive structure does not punish avoidance. It rewards it, in the narrow sense that it rewards not being wrong in a visible and embarrassing way. So, the gap persists, not because the question is frivolous. It was published in a peer-reviewed journal and has not been formally refuted, but because the machinery, that would normally pull curious researchers toward an open question is running in reverse on this one. Meanwhile, the same scientific community that has spent 7 years not formally following up on this question has collectively invested billions of dollars and decades of institutional energy into searching for microbial life on Mars. And that investment is not irrational. Finding any life at all on another planet would be one of the most significant discoveries in human history, and Mars is the closest and most accessible candidate. But what has that investment returned so far? Beautifully detailed images of red dust, mineral surveys of a surface that has been geologically dead for hundreds of millions of years, careful and technically extraordinary work that has, to date, not produced a single confirmed organism, a single strand of anything alive, a single molecule that unambiguously points to biology rather than chemistry. We have pointed our most expensive instruments at a cold, airless, largely featureless desert world for decades, on the off chance that something microscopic once lived in ancient brine beneath its surface. And sitting in our own geological record, in samples that have already been collected from every major ocean basin on this planet, accessible in repositories that researchers visit regularly, is a formally published and peer-reviewed question about whether a prior technological civilization's chemical signature might be embedded in a layer of rock we have studied for 30 years without a satisfying natural explanation. The gap between those two investments, the billions spent looking outward at a dead planet versus the near total silence surrounding a question in our own backyard, is not a funding problem. It is a comfort problem. Mars cannot implicate us. Mars cannot make the history of this planet strange in a way that is personally unsettling to the people doing the work. A microbe on Mars is a thrilling discovery with no uncomfortable implications for what we thought we knew about ourselves. The PETM question, taken seriously, has implications that run in a very different direction. We are the species that points expensive telescopes at dead planets, looking for microbes while leaving a formally published question about our own geological record sitting unanswered for 7 years. What does that tell you about what we are actually afraid to find? And the silence itself is a kind of data. Not proof of anything, not confirmation, not a smoking gun, but a signal that the professional and psychological cost of this particular question is higher than the cost of comparable questions, and that the gap in the literature reflects something more than a neutral allocation of research attention. The question exists. The model is rigorous. The match between prediction and measurement is specific and detailed. And the field has moved around it the way water moves around an obstacle, not confronting it, not refuting it, simply flowing in every other available direction. So think about where that leaves us. Not as a scientific community making collective decisions about where to point its resources, but as a civilization currently writing its own signature into the rock. What would you actually find if you came back to this planet 50 million years from now and started looking for us? Not what you hope, what the physics allows. So take that question seriously for a moment, not as a rhetorical gesture, but as an actual exercise. Take everything that human civilization has built and done since the Industrial Revolution began roughly 150 years ago. Every city that has ever existed in its modern form, every highway and bridge and airport runway, every power plant and factory floor, every undersea cable and cell tower and shipping container stacked in every port on every coastline. Take all of it and leave it alone for 50 million years. Then come back and look for it. The first thing that disappears is the thing you would expect to last. Plastic feels permanent because it resists degradation in the timescales of a human life. You throw a bottle into the world, and it does not decompose the way an apple does. And so there is a common intuition that plastic is somehow durable in a geological sense, that it will persist. But the geological timescale does not care about what feels permanent to you. Within hundreds of thousands of years, the vast majority of plastic produced by human civilization will have broken down through photodegradation, mechanical weathering, and chemical decomposition into forms that leave no legible trace in the rock record. We produce over 400 million tons of plastic every year, enough volume to register as a significant geological deposit If you compressed it all into one place, and virtually none of it will leave a recognizable artifact at the 50 million year mark. The quantity is staggering. The durability is not. And that is the plastic. That is the substance we have built to resist breakdown. The concrete comes next, and the steel, and the glass, and the composite materials, all dissolving on their own timescales, all returning to chemistry long before the 50 million year mark arrives. Cities do not become ruins in this time frame in any sense that would tell a future geologist what they were. A city buried under sediment for 1 million years becomes a layer of chemically unusual soil, measurably different from the surrounding geology, carrying trace metal signatures from industrial activity, perhaps showing disrupted mineral ratios that would catch a careful analyst's attention. But at 50 million years, even that layer has been compressed, folded, sometimes subducted beneath tectonic plates, sometimes reworked by groundwater chemistry until the signal that once read as unusual has blended into the background noise of the surrounding rock. The structures are gone. The records are gone. The distinction between what was a city and what was a forest floor has largely collapsed into the same sediment. What remains, in any meaningful sense, are 3 things. Trace metal anomalies at certain industrial sites, subtle enough that they might read as a localized geochemical curiosity rather than a signature of manufacturing. Isotope ratios preserved in carbonate rock laid down during the period of heaviest industrial output, because ocean chemistry records what flows into it, and the ocean floor is one of the most reliable long-term archives that geology has. And the carbon. The volume and isotopic character of the carbon that industrial civilization has added to the atmosphere and ocean over the course of 150 years, which ultimately settles into the sedimentary record and stays there in a form that can still be read tens of millions of years later. 150 years of industrial output has added roughly 500 billion tons of biologically fingerprinted carbon to the system. Carbon drawn from ancient biological sources. From coal, from oil, from gas formed from the compressed remains of organisms that lived and died hundreds of millions of years ago, and released in a burst that is, by geological standards, essentially instantaneous. That carbon carries the same light isotopic signature that any organism-derived carbon carries, the same preferential weight that distinguishes biological carbon from volcanic carbon, the same fingerprint that a future geochemist running isotope ratios on a core sample would recognize as a pulse of biological carbon with no obvious natural explanation. No structures, no records, no indication of the scale and complexity of what we built and knew and lost. Just chemistry. Sit with that for a moment. A few centimeters. That is everything. Because that is the actual width of the rock layer that all of this compresses into. The entire span of industrial civilization, every city that has ever hummed with electricity, every aircraft that has ever crossed an ocean, every conversation ever recorded on a server somewhere, every book and painting and film and scientific paper and medical breakthrough, every war and every peace treaty and every child born into all of it. At 50 million years, that entire accumulation of human activity, in physical terms, occupies a layer of sedimentary rock roughly the width of 2 or 3 stacked coins. The chemistry inside that layer is detectable. The story it tells is not. A future geologist studying that core would see a carbon anomaly with a biological isotopic signature and a volume that exceeds what known natural mechanisms of the period could account for. They would write papers about the possible sources. They would argue about whether methane reservoirs could explain it, whether orbital cycles might have triggered a cascade, whether some unknown volcanic mechanism might have produced the fingerprint. And sitting in that layer, invisible and unreadable, would be everything we ever were. That is the signal we are writing into the record right now, with every year of continued industrial output. 500 billion tons of biologically fingerprinted carbon, and rising, compressing toward the same kind of isotopic anomaly that survives 50 million years intact. That shows up in core samples pulled from the Atlantic and the Pacific and every other major ocean basin on this planet. The same kind of anomaly that we have already found in a layer of rock from 56 million years ago, that we have studied for 30 years, that we have named and catalogued and written hundreds of papers about, and that we have never fully explained. And here is the thing about that anomaly. The one from 56 million years ago, the one we have named and catalogued and filed and written hundreds of papers about. When you sit down and compare it directly to what industrial civilization has been writing into the rock over the last 150 years, you are not looking at a rough approximation or a suggestive similarity. You are looking at the same fingerprint, the same preferentially light isotopic signature, indicating carbon drawn from biological rather than geological sources. The same volume that exceeds what the known natural mechanisms of the period can account for. The same pattern of ocean chemistry disruption, the same sedimentary signature spread across cores pulled from every major basin on the planet, the same institutional response, which is to say, decades of careful study, hundreds of published papers, and no complete explanation. We found a carbon anomaly in the geological record, and we could not identify its source. We are currently producing a carbon anomaly in the geological record, and we are the source. The fingerprint is the same. The open question about volume is the same. The signal is not approximately similar to what we are writing. It is chemically identical to what we are writing. Does that last sentence sound familiar? Because that is the PETM. Exactly. Not approximately. Not structurally analogous. Not a useful comparison for illustrative purposes. The same isotopic signature, the same scale of disruption, the same absence of a tidy natural explanation in the record. That is the situation. And the reason it took 30 years of active research just to narrow the candidate sources without closing the gap is precisely because the signal is anomalous in the way that our signal is anomalous. It looks like something drew from a biological reservoir faster than any known natural process can account for. Now consider the timeline, because this is where the distance between 56 million years ago and today stops feeling like distance at all. Modern humans, our species, anatomically modern Homo sapiens, have existed for roughly 300,000 years. That is the full span of our presence on this planet. From the earliest individuals whose bones we have found and dated in Morocco to everyone alive right now. 300,000 years is a long time by any measure that makes intuitive sense to a human being. It encompasses thousands of generations, the entire development of language and culture and agriculture and industry, every civilization that has ever risen and fallen, everything recorded and unrecorded that our species has ever done or thought or built. 300,000 years is essentially the entirety of human experience. The PETM lasted 200,000 years. The entire episode, the carbon pulse, the temperature spike, the ocean disruption, the mass extinction in the deep sea, the long, slow recovery, all of it, start to finish, fits inside a window that is shorter than the time our species has existed. A civilization that arose 100,000 years into human existence and ran for 200,000 years before collapsing entirely would still fall within the span of our species' presence on Earth. The event that follows from it, the geological anomaly it left behind, the carbon pulse that altered ocean chemistry across the entire planet, all of that could have happened and resolved and been buried and compressed and transformed into a layer of chemically unusual rock before our most recent ancestors walked out of Africa. The PETM fits inside our existence, the way a chapter fits inside a book. Sit with that for a moment, because the geometry here matters enormously. We have been treating 56 million years as a vast and unbridgeable remove. But the episode itself, the duration of whatever process produced that signal, is shorter than we are. And then step back further, because the scale of what we are assuming when we say we are the first becomes clearer when you hold it against the full span of complex life on this planet. Earth has been habitable for organisms of significant biological complexity for roughly 600 million years. Not microbial life, which goes back much further, but the kind of life that builds structures and occupies ecological niches and leaves fossils. The kind of life that, given enough time and the right pressures, produces intelligence. 600 million years is the window. Humans, all 300,000 years of us, represent approximately 1/1200th of 1% of that window. Another way to hold it, if the 600 million year span of complex life on Earth were compressed into a single calendar year beginning on the 1st of January, modern humans would appear somewhere in the final 2 hours of December the 31st. Industrial civilization, the last 150 years, would occupy roughly the final 8 seconds before midnight. That is the sliver we are speaking of when we speak of ourselves. And the assumption embedded in every serious scientific conversation about this, the assumption that we are the first species on this planet to reach the level of complexity required to alter atmospheric chemistry, rests entirely on that 8 seconds. It rests on the idea that in the previous 364 days and 22 hours of that compressed year, nothing comparable ever emerged. Nobody has calculated the probability of that seriously. The reason, as Schmidt and Frank note with characteristic care in their paper, is that doing so requires taking the Silurian hypothesis seriously, and taking the Silurian hypothesis seriously is professionally uncomfortable in ways that studying ancient carbon anomalies is not. The math, though, is simply sitting there. 600 million years, 1/1200th of 1% of it occupied by us. The fingerprint in the record matching ours exactly. What if we are not the exception? What if we are the pattern? Because if a civilization can rise and produce an unmistakable geochemical signal and vanish without a physical trace within 200,000 years, which the PETM timeline shows is geometrically possible, then the question is no longer whether such a thing could happen. The question becomes what actually produced that signal 56 million years ago. Either something industrial contributed to the PETM, or we have accidentally reproduced the chemical signature of one of the largest extinction events in recent Earth history. Here is my position on that. Both of those options are serious, and neither of them is being treated with the weight that the evidence, patiently assembled over 30 years of ocean cores and isotope ratios, would seem to demand. And that position becomes harder to dismiss the moment you stop treating it as philosophical and start treating it as physical. Because the mirror is not impressionistic. The mirror is numerical, and the numbers have been sitting in the public record for years without receiving the weight they deserve. The current rate at which industrial civilization is adding carbon to the atmosphere falls within the lower range of estimates for the rate of carbon release at the beginning of the Paleocene-Eocene thermal maximum. Not in the neighborhood of it, not in the same rough order of magnitude, within the range. The projections for global temperature by the end of this century, which climate models have refined over decades of increasingly careful work, land at the low end of the temperature jump recorded in the PETM layer, somewhere between 5 and 8 degrees Celsius above the pre-industrial baseline, which is precisely where the PETM signal begins. We are not drawing a loose analogy between two vaguely similar events separated by 56 million years. We are tracing the same line from the same starting point. The rate matches. The trajectory matches. The isotopic fingerprint matches. And there is one more thing that matches, which is the part of this comparison that tends to get passed over quickly in the literature, and which should not be passed over quickly at all. Whatever produced the PETM signal did not make it to the other side. There is no second chapter in the record. There is the carbon spike, and the warming, and the mass extinction of deep sea life, and the 200,000-year recovery, and then silence from whatever process initiated it. Not a gradual tapering. Not evidence of a source that continued operating and eventually corrected course. The signal rises, the consequences play out across geological time, and the initiating cause is simply absent from everything that follows. The gap, in this sense, is not just a gap in our knowledge, it is a gap in the record itself. We are not analogous to whatever caused the PETM. We are chemically identical to it. Consider what that means, not as metaphor, as measurement. So think about where that leaves us, and then let me introduce something that does not get discussed in the same breath as the PETM nearly often enough. Because it should be. Because the evidence is forensic in a way that the PETM, for all its force, cannot quite claim to be. 12,800 years ago, something happened to this planet that has left physical markers at more than 50 sites across 4 continents, all deposited within the same geological instant, all consistent with a single catastrophic event, and all requiring an explanation that the scientific community spent several decades resisting before the weight of accumulated evidence made resistance increasingly difficult to maintain. We are talking about the Younger Dryas onset, a period of rapid, severe cooling that lasted approximately 1,200 years and appears in ice cores, lake sediments, and peat bogs across the northern hemisphere as one of the most abrupt climate reversals in the past 20,000 years of Earth history. The cooling itself has been known for a long time. The explanation for what triggered it has not. What began emerging from excavations across multiple continents, published in serious peer-reviewed journals over the last 2 decades, is a layer. A thin, dark, chemically distinctive layer of sediment sitting at the precise stratigraphic boundary where the Younger Dryas begins, appearing in North America, in Europe, in the Middle East, in South America, and containing a suite of physical markers that cannot be produced by ordinary geological processes. Each marker, taken alone, might invite alternative explanations. Taken together, they narrow the field of possible causes until only one remains. The first is nanodiamonds. These are microscopic crystals of diamond, measured in billionths of a meter, that form only under conditions of extreme pressure and temperature. The kind of pressure and temperature produced by a cosmic impact, or by a nuclear detonation, and by essentially nothing else that occurs at the Earth's surface. They are present in that layer. They are not present in the layers immediately above or below it. They do not occur in the surrounding sediment at anything resembling comparable concentrations. Their presence at over 50 separate sites, distributed across 4 continents, means that whatever produced them was not a local event. The second is magnetic microspherules. These are tiny spheres of metal, formed when rock is heated so rapidly and so completely that it melts, becomes airborne, and then solidifies in flight, essentially microscopic droplets of molten stone that cooled before they could settle back into the irregular shapes that ordinary rock takes. They are scattered through the same layer at the same sites, alongside the nanodiamonds. They require temperatures that no volcanic eruption, no wildfire, no flood produces. They require something that converts solid rock to liquid and then to airborne droplets faster than the eye could follow. The third is iridium. This element is extraordinarily rare in the Earth's crust. It tends to sink toward the planet's iron core during the early stages of planetary formation, which means the surface rocks we stand on contain almost none of it. Asteroids do not have this problem. Cosmic bodies that formed without the same geological differentiation retain their iridium in concentrations orders of magnitude higher than what you find in terrestrial surface rock. The presence of iridium in a sedimentary layer is one of the clearest signals in geology that something arrived from outside the Earth. It is the same signal that allowed scientists to identify the Chicxulub impactor responsible for the end Cretaceous mass extinction. And it appears in the Younger Dryas boundary layer. The fourth is shocked quartz. This is a form of quartz crystal that carries internal fractures arranged in precise parallel planes, a structure that forms only when rock is subjected to instantaneous pressures measured in gigapascals, pressures produced by meteor strikes and nuclear explosions, and by nothing else in nature. Geologists have known how to identify it for decades. It is present in the layer. And then there are the fires. Synchronized continental scale burning events, evidenced by the concentration of carbon and charcoal in that same boundary layer across 3 continents, suggesting that whatever struck this planet 12,800 years ago did not merely crater the ground at the point of impact. It ignited the landscape across an area of surface that no localized event could explain. The gap in the record at the Younger Dryas onset is not a gap of interpretation. It is a physical scar. replicated in 4 continents of sediment, marked with materials that nature produces only under conditions of catastrophic and sudden violence. The forensic case does not require speculation. It requires only a willingness to read the evidence in the same way a prosecutor reads a crime scene, not by looking for the most comfortable explanation, but by asking what suite of conditions could produce every item on the list simultaneously. Nanodiamonds, microspherules, iridium, shocked quartz, synchronized fires, and an instantaneous climate reversal that lasted 1,200 years. The explanation that fits all of them is a cosmic impact event, possibly a fragmented body, possibly distributed across a wide atmospheric corridor, possibly striking ice sheets rather than bedrock in ways that would complicate the search for what the evidence unmistakably demands. A crater. And the crater exists. That part of the story is no longer a matter of inference or projection from the forensic residue. It is a measurement. In 2017, radar imaging of the Greenland ice sheet revealed a depression in the bedrock beneath the ice. Circular, structurally consistent with a hypervelocity impact, and measuring 31 kilometers across. It sits under 900 meters of glacial ice, which is precisely why no one found it with ground-level surveys or aerial photography across the previous century of Arctic exploration. The technology required to see it simply did not exist until recently. But the depression was always there, waiting under a thickness of ice that would bury a skyscraper more than twice over, patient in the dark. 31 kilometers is a number that benefits from being made physical. If you took a major city, not its suburbs, not its commuter belt, but the dense urban core, and set it inside this crater, you would still have room to spare around the edges. You could fit the entire footprint of a city like Paris or Chicago within the rim wall of this structure, and the crater would not be full. That is the size of the wound. And that wound was initially dated. Through the isotopic and geological analysis of the surrounding ice, to the same narrow window already written in nanodiamonds and iridium and shocked quartz across 4 continents, approximately 12,800 years ago. The same moment, the same boundary. The forensic evidence that had been read from sediment on 3 separate landmasses now had, directly beneath the ice that formed from that era's disrupted climate, a physical structure of the scale required to produce it. And here is what was happening on the surface of this planet at that moment. The Clovis people, a culture distributed across an area so vast that it stretched from the forests of what is now Canada down through the full length of the Americas to the tip of South America, were, by any archaeological measure, thriving. Their tools appear at sites spanning tens of thousands of kilometers. They were successful enough and widespread enough that their artifacts serve as one of the clearest stratigraphic markers in the record of human habitation of the Western Hemisphere. And then, in one generation, the cultural signature vanishes. Not gradually, not in the slow way that populations shift and reorganize over centuries of climate pressure. The Clovis pattern, the particular tool assemblages, the material signatures, the evidence of continuity, disappears within a generational span, precisely at the impact boundary. You are looking at an entire continent of people, a civilization distributed across more territory than any other culture of its era. And the record shows them, and then it shows the boundary layer, and then it does not show them anymore. That timing is not an interpretation. It is a stratigraphic fact. The boundary layer containing the nanodiamonds and the microspherules and the iridium sits directly beneath the horizon, where the Clovis record ends. This is not a case where archaeologists are trying to correlate 2 events that happened within the same millennium and calling them simultaneous. The resolution of the record places them at the same geological instant, and at that same instant, across 4 continents that had no contact with one another, the large animals died. In North America, mammoths, mastodons, horses, camels, a giant ground sloths, entire genera of megafauna that had persisted through multiple glacial cycles, through previous climate shifts, through ice ages that remade the continent's geography, suddenly gone. In Eurasia, woolly mammoths, whose range stretched across a continent, collapsing at the boundary. In Australia, large fauna that had survived everything the Pleistocene could deliver, ending in the same window. The standard explanation offered for these extinctions is overhunting. Human populations expanding into new territories, encountering animals that had not evolved a fear of bipedal hunters, driving them to collapse through sustained predation. The overhunting hypothesis sounds reasonable. It sounds like the kind of thing that just happens when a capable predator meets naive prey. The problem is that it cannot explain synchronization across 4 continents with no contact between them. A hunting pressure collapse in North America does not simultaneously drive Australian megafauna to extinction. A regional cause produces regional extinction. A synchronized global extinction requires a synchronized global cause. That is not a philosophical position. That is a constraint imposed by basic causality. 2 explanations exist for the Younger Dryas and the extinctions and the Clovis collapse. One covers the cooling. One covers the entire list of physical evidence. The nanodiamonds, the iridium, the spherules, the shocked quartz, the fires, the crater, the synchronized extinctions, the vanished culture. The meltwater hypothesis, the idea that a pulse of fresh water into the North Atlantic disrupted ocean circulation and triggered the cooling, has been the dominant framework since the 1980s, built over decades, attached to careers and funding cycles and graduate dissertations and textbooks already in print. Changing that consensus does not require only new evidence. It requires an entire generation of researchers to acknowledge that their foundational framework covered a subset of the data and called it complete. That is not a scientific objection. That is an institutional one. And institutions, as the PETM record already showed us, are capable of sitting with an incomplete explanation for a very long time before they allow the full weight of the evidence to land. The physical record does not have this problem. The physical record simply shows what it shows. A horizon in the sediment. 31 kilometers of depression in Greenland bedrock. The bones of animals that crossed multiple ice ages only to stop at a single boundary. And the last tools of a people who had walked to the end of the world and then, in one generation, were gone. What do you build when you have just watched the world end? The people who survived that boundary built something. That is the part of this story that most accounts skip past, because what they built does not fit the category we have assigned to them. We call them hunter-gatherers. We place them in a developmental stage we associate with subsistence, with small bands, with tools made from flint and bone, and an intellectual horizon defined by the next meal. And then we discover what they actually constructed, and the category breaks. Göbekli Tepe sits in what is now southeastern Turkey, and it was excavated over decades by Klaus Schmidt, who dedicated the last 20 years of his life to the site before his death in 2014. What Schmidt found was a complex of at least 20 circular enclosures, covering an area of roughly 90,000 square meters, which is a number that does not become real until you try to walk across it. 90,000 square meters is a site larger than many modern city blocks, carved and organized and built up with enormous deliberateness, sitting on a hilltop in the ancient Near East, dated to approximately 11,500 years ago. Not 5,000 years ago. Not the period we associate with the first organized civilizations of Mesopotamia. 11,500 years ago, which means that whoever built this structure was working 6,000 years before Stonehenge was raised, and 7,000 years before the first Egyptian pyramids were laid down. If you compress the distance between Göbekli Tepe and the Great Pyramid into a single kilometer, Stonehenge would appear 100 meters before the pyramid's end, and Göbekli Tepe would be sitting a full kilometer back, in open ground, with nothing nearby for comparison. The pillars are what break the hunter-gatherer framing most completely. The largest T-shaped limestone pillars at the site stand over 5 meters tall and weigh up to 10 tons. They were quarried from bedrock, approximately 500 meters away, which means someone organized the extraction of multi-ton stone blocks from living rock, transported them half a kilometer across terrain, lifted them into upright positions, and arranged them with enough geometric precision that the enclosures repeat a consistent architectural logic across the entire site. This was accomplished without the wheel, without draft animals, without any of the organizational infrastructure we associate with large-scale construction. What it required was coordinated human labor operating under deliberate, sustained, and sophisticated direction. The question of who was directing that labor and what knowledge they were working from is the question the site forces on you whether you wanted to or not. The carvings are specific. The animals depicted on the pillars are not generic decorative fauna. They are rendered with enough accuracy to be identified by species, positioned with enough intentionality that researchers have spent years studying their arrangement. And then there is Pillar 43, which researchers at the University of Edinburgh analysed and published findings on. A panel now sometimes called the vulture stone. The configuration of animals and symbols carved into Pillar 43 encodes a specific astronomical arrangement, the positions of constellations as they would have appeared from that location at a specific date. The date encoded in the stone is approximately 10,950 years before the Common Era. That number will be familiar to you. The beginning of the Younger Dryas impact event. The moment the nanodiamonds were deposited. The moment the Clovis culture vanished from the record. The moment the synchronized extinctions began. The people who built Göbekli Tepe carved the date of the catastrophe into their stone using the only reference system that any future civilization, regardless of what language they speak, regardless of what knowledge they inherit, can independently verify. The night sky is the same for everyone. The precession cycle runs on physics, not on cultural transmission. If you can read astronomical positions, you can read the date. Here is my position on that. This is not a temple in the religious sense we reach for when we encounter ancient construction we cannot otherwise explain. A temple is built to face inward, to serve the living community that built it, to anchor the rituals of a present tense culture. The fingerprint is not just in the rock, it is in the stone that someone carved with enormous effort and then hid underground for us to find. Because the site was deliberately buried, not abandoned, not collapsed into ruin, not slowly covered by centuries of windblown sediment, the way that unattended structures accumulate fill. Göbekli Tepe was filled in intentionally, covered under meters of material by the people who built it, sealed away from the surface with a thoroughness that preserved its carvings with a clarity that still stuns researchers who walk the excavation today. The act of building and the act of burying were both part of the same project. They built it to encode the information. They buried it to protect the encoding from whatever they knew came next. Think about what it means to be on the receiving end of that message. Someone in the immediate aftermath of a catastrophe that ended a world, that killed the megafauna, collapsed the cultures, and filled the record with nanodiamonds and fire, organized the most ambitious construction project their civilization had ever attempted, not to house a government, not to store grain, not to shelter the living, but to preserve a specific date in the most permanent medium available. Limestone is not chosen by accident. Stone weathers across geological timescales, and they buried it under fill so it would survive even that. This is information storage. This is a hard drive carved in limestone, pressed into the earth, designed to outlast everything that comes after the disaster, because the people who built it understood that everything after the disaster would start from zero and would need to know what happened and when. They were not building for themselves. The entire site is a message in a bottle. The bottle was buried 11,500 years ago, and we opened it in the 20th century, and the date encoded inside matches to the geological instant, the horizon where the world they knew ended. What does water erosion on a limestone structure actually tell you? What water erosion on a limestone structure tells you is this. Limestone weathers in very specific ways depending on what is doing the weathering. Wind-driven sand, which is what most people assume has shaped the monuments of the Egyptian plateau, produces horizontal striations. Shallow, parallel grooves running across the surface in the direction the wind blows, because the abrasive particles are carried laterally and they cut laterally. Rain does something entirely different. Rain falls vertically. It pools, it runs, it cuts downward through the stone along natural channels, producing deep vertical fissures that widen over centuries as water continues to follow the paths it has already worn. These are not similar-looking features that require expert judgment to distinguish. They are different in their geometry, different in their depth profile, different in their distribution across the surface. A geologist trained to read weathering patterns looks at a limestone wall and identifies the mechanism the way a physician identifies a disease from its presentation, not by guessing, but by reading a set of physical signs that each have only one cause. Robert Schoch holds a doctorate from Yale. His specialization is geology, and within geology, his particular expertise is the weathering and erosion of ancient stone. He visited the Sphinx enclosure for the first time in 1990, and what he found on the walls of the enclosure, not the Sphinx itself, but the limestone bedrock that was cut away to expose the monument, were vertical rainfall erosion channels. Deep, well-developed, clearly formed by sustained precipitation over an extended period. The kind of erosion that does not happen in a single wet season or even in a century of wet seasons. It requires thousands of years of significant rainfall to cut that deeply into bedrock limestone. The question Schoch asked is the right question. When was the last time Egypt had that rainfall? And the answer, drawn from climate records that are not in dispute, is that Egypt has not experienced sustained heavy precipitation since before 5000 BCE at the latest. The Sahara was once a wetter place, that is well established, but its last period of significant rainfall ended somewhere between 7,000 and 5,000 years ago, and it has been substantially arid ever since. The official date for the Sphinx is approximately 2500 BCE, a tribute to the pharaoh Khafre during the Old Kingdom period. But if the erosion in the enclosure requires thousands of years of rainfall to form, and that rainfall ended no later than 5000 BCE, then the structure was already old when Egypt went dry. The minimum age implied by the geology is not 2500 BCE. It is older by at least 2,500 years, and possibly by considerably more, not as a fringe assertion, not as speculation, as a direct reading of the physical evidence by a credentialed geologist applying standard methodology to observable weathering patterns. The objection from Egyptologists has never been primarily geological. Their response to Schoch's analysis has been, essentially, there is no other evidence of a civilization old enough to have built the Sphinx. No texts, no artifacts, no cities, no administrative records, nothing in the archaeological record that would support the existence of a monument-building culture in Egypt 8,000 or 10,000 years ago. That objection sounds decisive. It sounds like the kind of objection that closes the matter. But listen carefully to what it is actually saying. It is saying that the absence of surface evidence is evidence of absence. And if you have been paying attention to what the geological record actually preserves and destroys over tens of thousands of years, you already know that this argument has a significant problem. The astronomical evidence sits beside the geological evidence without requiring the other to be true, and it points to the same general window. Because the Earth's axis wobbles on a cycle of roughly 26,000 years, the same precession cycle encoded in Pillar 43 at Göbekli Tepe, the constellation that rises due east on the spring equinox changes slowly over millennia. At the latitude of Giza, the constellation Leo rose due east on the spring equinox, around 10,500 BCE. The Sphinx faces due east. Its body is a lion. The head, most researchers who have examined the monument carefully agree, is visibly disproportionate to the body, smaller than the proportions of the original carving would require, bearing the marks of a recut, a later reworking of whatever face was originally carved on the statue, likely by a pharaoh who wished to claim ownership of a much older structure. The original face is gone. What remains is a smaller head sitting on a body that was built for something larger. These 3 lines of evidence, the geology of the erosion, the astronomy of the alignment, and the physical evidence of the recarved head, each arrive at approximately the same period independently. That is not proof, but the convergence is not nothing. So where are the remains? Where is the civilization that could have quarried and positioned a limestone monument of that scale before the last period of Egyptian rainfall ended? Here is where Frank and Schmidt's paper and the broader geological argument this whole conversation has been building arrives at a direct answer. Between 15,000 and 7,000 years ago, sea levels rose by approximately 120 meters. 120 meters, not across a bay or a delta, globally. And the land that disappeared under that rise was not empty highland steppe. The land that went underwater was the coastal margins, the river mouths, the fertile floodplains, the shallow continental shelves, where fresh water meets salt water and sediment accumulates, and agriculture first becomes viable. The total area submerged during that period is roughly equivalent to the combined landmass of Europe and North America. Sit with that for a moment. Every coastal settlement, every river delta culture, every civilization that built its infrastructure on land that is now under 100 meters of ocean water left its physical record in a place that is completely inaccessible to conventional archaeology. The absence of remains is not evidence of absence. The remains are exactly where we have not looked, and in a condition of preservation that varies from unlikely to impossible, depending on how long they have been submerged and what has happened to them since. And then there is Derinkuyu. In Cappadocia in central Turkey, carved downward through the volcanic rock, there is an underground city that descends 18 levels beneath the surface. Not 18 floors of a building, 18 excavated levels of living space, storage, livestock areas, ventilation systems, and passageways cut from solid rock, designed to house approximately 20,000 people for an extended period. The ventilation shafts reach 200 feet down from the surface. There is an independent water supply. There is storage sufficient for years, not weeks. There are over 200 similar underground settlements in the same region of Cappadocia, connected by tunnels. At 18 levels, you are not hiding from soldiers. A military siege does not require you to go 200 feet underground and bring your livestock and your food supply and engineer a ventilation system capable of supplying breathable air to 20,000 people indefinitely. You go to that depth, and you build with that thoroughness when the thing you are hiding from makes the surface uninhabitable for years. Not dangerous, uninhabitable. The monuments, the underground cities, the geological evidence carved into limestone by rainfall that stopped millennia before the official histories begin. They are all pointing at the same general window of time. And they are all answering the same question in different registers. The coastal plains where Ice Age cultures would have concentrated are sitting under 100 meters of water. That is where the standard objection sends us. And there is another category of evidence entirely, one that does not require excavation, one that was never buried and never submerged, because it was carried in human memory across every culture on every continent. What do 500 independent flood myths actually tell us? The question of what 500 independent flood myths tell us is not primarily a question about mythology. It is a question about structure. Because if you collect those traditions from every inhabited continent, from Mesopotamia and coastal India, from the indigenous cultures of North America and the lowland peoples of South America, from Aboriginal Australian oral histories and sub-Saharan African traditions, from Southeast Asian island cultures and the Pacific archipelagos, and you lay them side by side, what you find is not a loose family resemblance. What you find is the same story. Not the same surface details, not the same gods or animals or geographic landmarks, but the same 4-part sequence. A previous world existed. A catastrophic flood destroyed it. One person or one family was warned in advance. A new world began from that survivor. That 4-part structure appears in traditions with no documented contact, separated by entire ocean basins, preserved in languages that share no common ancestor. The standard objection is that this proves nothing, that floods are universal because water is universal, and any culture living near rivers or coastlines will eventually experience devastating floods and build stories around them. That objection sounds reasonable. It sounds like the kind of thing that just happens. But the objection does not explain the structure. A local river flood produces a story about a local river flood. It does not reliably produce the same four-part sequence with a previous world, a cosmic-scale destruction, a warned survivor, and a new beginning. That specific architecture, that particular shape, is not the inevitable product of experiencing a flood. It is the product of experiencing a flood of a particular kind, at a particular scale, that felt like the end of a world. Because in practical terms, it was. Put yourself on a coastline where the sea is sitting 120 meters below the level it will eventually reach. The beach in front of you is not a short walk away. Between you and the water's edge, there are miles of what you would recognize as usable land. Forests, floodplains, river deltas, the kind of terrain where fresh water and salt water meet and sediment accumulates, and the soil is deep and rich and things grow. That is where your community lives. That is where your food supply is. That is where your trade routes run, where your boats are kept, where your children play within sight of the water. And then, over the course of generations, not in a single catastrophic moment, but across a human lifetime, across 2 or 3 human lifetimes, the sea begins to rise, not imperceptibly, fast enough that a person born on that coast will die watching the water cover the land where they spent their childhood. Fast enough that the forest their grandparents walked through is now submerged. Fast enough that within a few generations, the entire world as that culture understood it is simply gone, replaced by open ocean. And around 14,000 years ago, there was at least one pulse in that rise. A period during which sea levels increased by approximately 20 meters in the span of a few centuries. 20 meters is roughly the height of a 6-story building. Applied across a shallow continental shelf, a rise of 20 meters in a few centuries would push the coastline inland by miles, sometimes tens of miles, depending on the gradient of the seafloor. The people living on those margins did not experience a gradual adjustment. They experienced the disappearance of their world within the span of recorded human memory. The Black Sea flooding, which geological and oceanographic evidence dates to approximately 7,500 years ago, is one of the most precisely documented of these events. The current prevailing model holds that as global sea levels rose, the Mediterranean eventually breached the land barrier at what is now the Bosphorus Strait, and seawater flooded a freshwater lake at a rate and scale that would have been catastrophic for any communities living on its shores. That event has been proposed as one of the geological anchors for the Near Eastern flood traditions. The stories that eventually became the Epic of Gilgamesh. And from there, through a longer chain of transmission, the account in Genesis. Separately, the geological record shows that approximately 8,000 years ago, what is now the North Sea underwent a major inundation that permanently separated Britain from the continental European landmass. Before that flooding, Doggerland, the submerged plain that now lies under the North Sea, was inhabited territory, crossed by rivers, dotted with settlements, the home of communities whose entire world vanished underwater. These are not mythological events reconstructed from stories. They are dated geological events confirmed by sediment cores and seafloor mapping. The stories describe the events. The geology confirms they happened. Now, there is a piece of evidence that circulates in discussions like this one that I want to address directly, because I think intellectual honesty requires it. The Peary-Reyes map, drawn in 1513, has been claimed by some researchers to show Antarctica's coastline before it was covered by ice, interpreted as evidence of a sophisticated pre-Ice Age cartographic tradition. The Peary-Reyes map does not hold up as strong evidence. Here is my position on that. When the map is examined carefully, the coastlines attributed to Antarctica can be more plausibly explained by the combination of geographic speculation, distortion from the projection method used, and the conflation of South American coastline features. The claim requires the map to be more accurate than the evidence actually supports. I am not persuaded by it. And I think including it in this argument without that caveat would be dishonest. But disproving the weakest evidence in a case does not disprove the case. Which piece of the remaining evidence is actually wrong? The isotope anomaly at the Paleocene-Eocene thermal maximum is not explained by the Piri Reis map. The rainfall erosion on the Sphinx enclosure walls is not explained by the Piri Reis map. The astronomical encoding at Göbekli Tepe and the deliberate burial of the site are not explained by it. The 500 independent flood traditions sharing the same four-part narrative structure are not explained by it. The geological confirmation of the Black Sea and North Sea flooding events is not explained by it. Setting aside the weakest evidence leaves the rest of the structure intact. And the structure is pointing at the same place it has been pointing the entire time. At the drowned continental margins, sitting under 100 meters of ocean water, where we have barely looked, and where the most concentrated evidence of Ice Age coastal settlement would be, if it existed. We have spent billions of dollars and decades of institutional energy searching for microbial life on Mars. We have sent orbiters and landers and rovers to a planet that has been geologically dead for hundreds of millions of years, looking for the chemical residue of biology in ancient rock. The seafloor of the North Sea and the submerged continental shelves of the Indian Ocean and the drowned coastal margins off the shores of every inhabited continent have received a fraction of that attention. The absence of confirmed evidence from those locations is not a refutation. It is a description of where we have and have not pointed our instruments. And the myths remember something. Whatever else they are carrying a geological event across 10,000 years of human memory in the only format that survives when the physical record goes underwater. Story. Now look at today. Not at ancient history, not at the geological past. At the numbers being published right now. The Gulf of Cambay sits off the northwestern coast of India, and in 1999, marine archaeologists working with the National Institute of Ocean Technology found something under 40 meters of water, roughly 9,500 years old. The remains of what appears to be a structured settlement, with geometric patterns in the seafloor consistent with human construction, sitting at a depth that was dry land before the ice melted and the oceans rose. The site remains disputed. The methodology of the acoustic imaging used to identify it has been questioned, and the artifacts recovered from the area have not satisfied every researcher working in the field. And the Yonaguni structures off the southern coast of Japan, those massive stepped stone formations sitting underwater near the Ryukyu Islands, have been argued over for decades, with geologists divided between natural formation and human construction, and no consensus reached. I raise both of them not to claim they are definitive proof of anything, but to say this. These are the kinds of structures we have found in shallow coastal waters, when we have actually looked, and we have barely looked. The continental shelves that were dry land during the last ice age run from a few meters of depth to the full 120 meter mark, stretching outward from every inhabited coastline on Earth. And our systematic survey of those areas as potential archaeological zones is, by any honest accounting, nearly non-existent. And that brings us back to the comparison that does not go away. We have spent billions of dollars and many decades of concentrated institutional effort searching for microbial life on Mars, a planet geologically dead for hundreds of millions of years, where the best we can hope for is chemical residue in ancient rock. Meanwhile, the submerged continental shelves of the Indian Ocean, the drowned coastal plains of the North Sea, the flooded margins of the South China Sea, the shallow underwater terraces off every coastline where Ice Age populations actually lived and gathered food and built fires. Those locations have received a fraction of that attention, that funding, that urgency. We know more about the surface geology of Mars than we know about what is sitting under 40 meters of water off the coast of India, or under 60 meters of water in the Gulf of Mexico, or under 80 meters of water in the Sunda Shelf between Sumatra and Borneo, where tens of thousands of years of human habitation would have concentrated precisely because coastal environments were where food was most abundant and water was most reliable. What does that tell you about what we are actually afraid to find? Because it is not a resource problem. It is not a technology problem. The tools exist. The ships exist. The imaging equipment exists. Something else is doing the prioritizing. And whatever it is directing our attention consistently away from the places where the evidence would be most likely to exist. Now, look at today. Not at ancient history, not at the geological past. At the numbers being published right now in journals by researchers who are not making an argument about lost civilizations, but simply measuring what is happening to the atmosphere and the oceans and the ice. The ice cores from Antarctica carry a continuous chemical record stretching back 800,000 years. In that record, you can read every warm period and every cold period, every natural fluctuation in carbon dioxide and methane, every cycle of ice advancing and retreating across the continents. And in 800,000 years of that record, there is no precedent for the rate at which carbon dioxide is currently increasing in the atmosphere. Not the level, the rate. How fast it is climbing. The current trajectory is faster than anything the ice has recorded in 800,000 years of planetary history. That is not a projection. That is a measurement of what has already happened. Since the pre-industrial period, since roughly the middle of the 19th century, when industrialization began generating carbon emissions at scale, global average temperature has risen approximately 1.2 degrees Celsius. That number sounds modest. 1.2 degrees in a century and a half sounds like the kind of variation you might notice between one decade and the next in a local climate. The kind of thing that could plausibly be within the range of natural fluctuation. But this is not a local measurement. This is the average temperature of the entire planetary surface, land and ocean combined, measured against a stable baseline that persisted for thousands of years. A shift of 1.2 degrees at that scale represents an enormous transfer of energy into the climate system, into the oceans, into the atmosphere, into the polar ice that regulates sea level and reflectivity for the entire planet. And the end-of-century projections, depending on emissions trajectories, range from 2 to 4 additional degrees Celsius, beyond where we are right now. Which means the lower bound of where we may be heading sits at the lower bound of the Paleocene-Eocene thermal maximum. The event we started with, 56 million years ago. The one with no complete natural explanation. The one that killed a third of deep-sea life and took 200,000 years to recover. But here is the part that keeps researchers who study the PETM awake at night. And it is not the temperature number itself. It is what the geological record shows happened after the initial carbon was added to the system. The warming at the PETM did not stop when the initial carbon input ended. It continued. The planet crossed some threshold, the exact mechanism is still being worked out. But the most credible explanations involve self-sustaining feedback loops that took over after the initial trigger. Permafrost thawing and releasing the methane frozen inside it for thousands of years. Warming oceans releasing the carbon stored in deep water that had been sequestered over millions of years. Ice retreating and exposing darker ocean and land surface, which absorbs more solar energy instead of reflecting it back into space, which warms the planet further, which melts more ice, which exposes more dark surface, each loop feeding the next. The warming became its own engine, and the geological record shows it ran for tens of thousands of years before the system found a new equilibrium, an equilibrium that looked nothing like the world that preceded it. We are approaching a threshold. We do not know where it is. The honest scientific position is that the feedback loops are real, the mechanisms are measured and confirmed, and the location of the point at which they become self-sustaining is genuinely uncertain. Not because the research is poor, because the climate system is complex enough that the threshold is not a single fixed line, but a range, and we are moving toward it at a rate with no precedent in 800,000 years of ice core data, in a system whose behavior at the edge of that range we have never directly observed. We are not watching this from a historical distance. We are not studying it as archaeologists study an extinct civilization, reading the signal in rock and asking what happened. You are living inside the event, not watching it, not studying it from a safe historical distance, inside it right now, this year, this decade, and the carbon we are releasing is being locked into ocean sediment. The isotopic signature, the chemically distinct fingerprint of biologically processed carbon, the same signature that makes the PETM anomaly identifiable at 56 million years of distance, is being written into the geological record right now, in this century, at a rate that will make our industrial period visible in rock for as long as rock holds its chemistry. Whatever comes after us, in whatever form, will be able to read it. The question the entire structure of this argument has been building toward is not whether that signal will exist. It is whether we are the first civilization to write it. So think about where that leaves us. The carbon is in the sediment. It is going in now, this decade, at the rate of hundreds of millions of tons per year, and it carries the same isotopic signature, that ratio of carbon 12 to carbon 13 that geochemists use to identify biological origin. That has made the PETM anomaly readable at 56 million years of distance. We identified the PETM fingerprint in ocean cores pulled from every major body of water on the planet. We read it in carbonate rock laid down while the first large mammals were finding their footing in a world still warm from whatever happened. We can read it because chemistry preserves what narrative does not. And we are writing the same chemistry right now into the same kind of rock, in the same kind of ocean, at a rate that will make our industrial century stand out in any core sample pulled by any instrument capable of measuring isotope ratios, whether that instrument is held by a human hand or something else entirely. The signal will be there. The carbon layer will be there. And alongside it, if the researchers are careful enough, will be other things. Trace metal concentrations unlike anything the surrounding geology produces naturally. The signature of cities, of mines, of industrial scale smelting concentrated at locations that correspond to no volcanic event, no meteor impact, no known geological process. Lead, mercury, arsenic, cadmium, in ratios and concentrations that require explaining, if explaining is what whoever finds them tries to do. And depending on how this century resolves certain questions, there may be something else layered into the rock above our industrial stratum. Radioactive isotopes with half-lives measured in the thousands to millions of years. The unmistakable signature of nuclear technology, readable not as a natural decay profile, but as something concentrated, anomalous, present in geological quantities that no supernova fallout or natural uranium deposit would produce in quite that configuration. That layer will be readable. Every major component of it will require explanation. Now imagine what the explanation process looks like from the other side of geological time. The Milankovitch cycles will continue. They do not stop for us. The orbital mechanics that have driven glacial and interglacial periods for hundreds of millions of years will keep operating on their schedules. The wobble, the tilt, the variation in orbital eccentricity, and eventually, on a timescale measured in tens of thousands of years, the current interglacial will end. What follows may be different from previous glacial periods if the feedback loops we are currently loading into the climate system have shifted the baseline. But the planetary processes will continue, and within the next 100 million years, the conditions that allow complex life to develop, to persist, to build things and ask questions will reassert themselves on this planet or elsewhere. 100 million years is deep time, but it is not forever. Complex life appeared here after 1 billion years of simpler chemistry. 100 million years is an eye blink relative to that. And somewhere inside that future, there may be something that studies the past the way we study it. Something that collects core samples, something that reads isotope ratios, something that sits in the equivalent of a university or a research institute and looks at a layer in the rock that corresponds to roughly our present moment and notices that the layer is strange. The carbon is wrong. The trace metals are wrong. The radioactive profile is wrong. The layer represents a planetary scale chemical disruption that happened very fast. Geologically speaking, overnight, and left a signature unlike anything the surrounding stratum explains. And some researcher, or whatever a researcher is in that context, writes a paper. The paper notes that the known natural explanations are insufficient. The carbon signal points to biological origin, but the scale and rate exceed any identified volcanic or clathrate source for that period. The trace metal concentrations correlate geographically in ways that suggest high-temperature industrial processing. The radioactive signature suggests controlled fission at a level nature does not produce. The paper asks a question carefully, the way Gavin Schmidt and Adam Frank asked their question carefully in their paper, published in 2018, and it arrives at the same conclusion they arrived at. The evidence is consistent with the existence of a prior industrial civilization, and the absence of recoverable physical structures is expected, given the timescales involved. The paper sits in whatever passes for a journal. It accumulates a handful of citations. It is met with 7 years of institutional silence. Because that is what happens when you ask a question the field is not prepared to answer. Not because the question is wrong, because it is uncomfortable in a way that the normal machinery of scientific discourse is not built to process quickly. Schmidt and Frank wrote their paper. It is real. It is peer-reviewed. It has been 7 years. The silence is not a refutation. The silence is a data point about how institutions respond to questions that do not fit inside existing frameworks, and it tells us something about what a future institution will do when it encounters our layer and someone asks the uncomfortable question about what made it. Here is where the full weight of the argument lands. What the Frank and Schmidt paper established is that there are only 2 honest positions, and both of them carry serious consequences. Either something industrial contributed to the PETM, something that burned through carbon at rates matching our own industrial output and left the same isotopic fingerprint, or the PETM was entirely natural, and we have managed, through our own industrial output across roughly 150 years, to accidentally reproduce the chemical signature of one of the most severe extinction events in the recent geological record. Both options are serious. The first option means we are not the first. The second option means we are writing the opening chapter of our own extinction event, in rock, in real time, with full knowledge of the PETM's outcome, and we have not changed what we are doing. And recognizing this has not, in any measurable sense, changed what we are doing. That is the loop. It closes here. 56 million years ago, something left a carbon layer in the rock that we have spent decades studying, that we have pulled from ocean cores across every major body of water, that we have analyzed against every natural explanation and found wanting. We named it, we filed it, we did not resolve it. And we are writing an identical layer into the rock right now, in this century, in these decades, in a quantity and at a rate, and with a chemical signature that will be just as legible, just as anomalous, and just as resistant to easy explanation as the one we are still debating. We are going to be someone else's unanswered question. The only thing that remains open is whether we left just the chemical layer, or whether we survived long enough to leave something more. Something that the next version of this question might read not as residue, but as a message. The layer is being written. What do you want it to say? There is a particular kind of silence that comes after a long argument, when everything that can be said has been said, and what remains is not more information, but the weight of what you already know. You have been carrying this argument for a while now, through ocean cores and isotope ratios, through buried cities and flooded coastlines, through the Younger Dryas boundary and the stones at Göbekli Tepe, through Schmidt and Frank, and the question they asked that nobody wanted to sit with. And now the argument is complete. What remains is the question of what you do with it, not what you do politically or scientifically or even practically. That is a different conversation for a different hour. The question that lingers here is simpler and older. It is the question of what kind of thing you are, sitting in whatever room you're sitting in this particular decade, on a planet that has been cycling through these temperatures before and will cycle through them again. You are a being capable of reading a layer of rock and understanding what caused it. You are capable of measuring a carbon isotope ratio and recognizing it as a signature. You are capable of pulling a core from the bottom of the Atlantic Ocean and matching its chemistry to a warming event 56 million years in the past. And you are doing all of this while generating the next layer in real time. This is not a passive situation you are observing from a distance. The carbon that we are releasing is being deposited right now, this decade, into ocean sediment, settling into carbonate rock at the bottom of every major body of water on the planet, building the stratigraphy that someone or something will read tens of millions of years from now, if anyone survives to read it. The layer does not care what caused it. That is the thing about chemistry. It survives everything else. The buildings will compress into nothing over geological time. The roads will dissolve and scatter. The written language will require an unbroken chain of living readers to remain meaningful, and chains break. What survives is the ratio of isotopes in rock. What survives is the anomalous concentration of lead and mercury in a thin band of sediment. What survives is the rate of carbon change, encoded in the shells of marine organisms that died quietly at the bottom of oceans we have never visited and will never visit. Chemistry survives. Everything else degrades. And so the fingerprint is the message, whether we intended it to be or not. We are the owners of the next fingerprint. We are writing it now. So think about where that leaves us. Every civilization that has ever asked a question about its own origins has done so inside a moment that was already becoming geological record. The PETM civilization, if there was one, almost certainly believed it was permanent. It believed its structures were real and lasting. It did not know that 56 million years later, the only evidence of its existence that would survive in any readable form was a smear of isotopically light carbon in a band of rock 3 centimeters thick. And here we are, having dug up that record, having read it with instruments it could not have imagined, and finding ourselves looking at a mirror. The question we cannot answer about that layer, we are answering about ourselves right now. We know the civilization that caused our layer. We are the civilization. We know what is here, in this moment, generating the signal. What we do not know, what is still genuinely open, is what comes next. And perhaps that is the only honest place to end, not with a resolution, because there is no resolution yet, only a process still underway. Not with despair, because despair is passive, and this moment is not passive, but with something closer to responsibility. The layer is going to exist regardless of what you do or do not do tonight. The carbon already deposited is already there, but the layer is not finished. It is being written in this decade and the next, and the ones after that, and chemistry is extraordinarily precise, and future readers will be able to tell the difference between a civilization that recognized what it was doing and changed course, and one that recognized what it was doing and continued. That distinction will survive in rock. That distinction is worth making. The layer is the only message that survives geological time. Make sure it says something worth finding.